Industrial facilities that fabricate control panels for in-house use are not required to label those panels. This exemption applies specifically when the panels are not sold or distributed to external parties. The labeling requirement, as outlined in the National Electrical Code, primarily targets panels intended for commercial sale or distribution to ensure compliance and safety standards are met for a broader audience. The primary reason for labeling is to provide essential information to electricians, technicians, and inspectors who may work on or around the equipment. This information typically includes the manufacturer's name, model number, electrical ratings such as voltage, current, and frequency, and the short-circuit current rating. The short-circuit current rating listed on a control panel refers to the maximum available fault current at the panel's installation location. This rating indicates the panel's ability to withstand the immense current that flows during a short-circuit event without failing catastrophically, which could lead to equipment damage, fire, or personnel injury. Determining the available fault current at the installation location is a critical step in ensuring the safety and proper functioning of electrical systems. This calculation or measurement involves considering the electrical supply source, transformer impedance, conductor sizes and lengths, and any other components in the circuit that may affect the fault current magnitude. To determine the available fault current, several methods can be employed. Firstly, a short-circuit study can be conducted by a qualified electrical engineer or technician. This study uses specialized software and calculations to model the electrical system and predict the fault current levels at various points, including the control panel's location. Secondly, the utility company may provide the available fault current at the service entrance. This information can be used as a starting point, but it is essential to account for any additional impedance in the system between the service entrance and the control panel. Thirdly, an impedance method can be used to calculate the fault current based on the impedance of the various components in the circuit. This method requires detailed knowledge of the electrical system and can be complex to implement accurately. Once the available fault current is determined, it is crucial to select a control panel with a short-circuit current rating equal to or greater than the calculated value. Installing a panel with an inadequate rating can create a significant safety hazard, as the panel may not be able to withstand a fault current, leading to equipment failure and potential injuries. If the available fault current exceeds the rating of the selected control panel, several mitigation techniques can be employed. Firstly, current-limiting fuses or circuit breakers can be installed upstream of the panel to reduce the magnitude of the fault current. These devices are designed to quickly interrupt the current flow during a short-circuit event, limiting the stress on the downstream equipment. Secondly, impedance can be added to the circuit to reduce the fault current. This can be achieved by installing reactors or transformers with higher impedance values. Thirdly, a different control panel with a higher short-circuit current rating can be selected. This is often the most straightforward solution, provided that a suitable panel is available. The National Electrical Code, or NEC, provides guidelines for calculating and applying short-circuit current ratings. NEC Article 110.9 addresses the interrupting rating, which requires that equipment intended to interrupt current at fault levels be rated for the available fault current at its supply terminals. NEC Article 110.10 addresses circuit impedance, short-circuit current ratings, and other characteristics. The intent is to ensure that equipment is selected and installed to withstand the forces imposed during a short-circuit condition. NEC Article 409 specifically addresses industrial control panels and provides requirements for short-circuit current ratings. It is important to consult the latest edition of the NEC and any applicable local codes to ensure compliance with all relevant requirements. UL 508 is a widely recognized standard for industrial control panels. It provides detailed requirements for the design, construction, and testing of control panels to ensure safety and performance. UL 508 includes specific requirements for short-circuit current ratings, including testing procedures to verify that panels can withstand fault currents without failing. Compliance with UL 508 is often required by regulatory authorities and end users to ensure that control panels meet industry best practices and safety standards. In addition to the NEC and UL 508A, Other industry standards and guidelines may be relevant to the design and installation of industrial control panels. These standards may address specific aspects of panel construction, such as wiring practices, component selection, and grounding requirements. Consulting with qualified electrical engineers and technicians is essential to ensure that control panels are designed and installed in accordance with all applicable standards and regulations. Proper training and experience are necessary to perform short-circuit calculations, select appropriate components, and install panels safely and effectively. When specifying or purchasing an industrial control panel, it is crucial to provide the panel builder with accurate information about the available fault current at the installation location. This information allows the panel builder to select components with appropriate short-circuit current ratings and to design the panel to withstand the expected fault current levels. Providing inaccurate or incomplete information can lead to the selection of inadequate components and potentially unsafe installations. The panel builder should provide documentation indicating the panel short-circuit current rating and the basis for that rating, including any calculations or test reports. This documentation should be kept on file for future reference and to demonstrate compliance with applicable codes and standards. Regular inspection and maintenance of industrial control panels are essential to ensure their continued safe and reliable operation. Inspection should include a visual examination of the panel for any signs of damage, overheating, or corrosion. Connections should be checked for tightness, and components should be tested to verify their proper functioning. Any discrepancies or issues should be addressed promptly to prevent potential problems. Maintenance should include cleaning the panel to remove dust and debris, lubricating moving parts, and replacing any worn or damaged components. A well-maintained control panel is more likely to withstand fault currents and operate safely and reliably over its lifespan. Understanding the requirements for industrial control panel labeling and short-circuit current ratings is crucial for ensuring the safety and proper functioning of electrical systems in industrial facilities. By following the guidelines outlined in the NEC UL 508A and other relevant standards, engineers, technicians, and facility managers can design, install, and maintain control panels that meet industry best practices and provide reliable performance. Remember to always consult with qualified professionals and stay up to date on the latest codes and standards to ensure the safety of personnel and equipment. Short-circuit current ratings are an important part of electrical safety. The consequences of ignoring these ratings can be severe, including equipment damage, fire, and personal injury. Always prioritize safety and follow established guidelines when working with electrical systems. Consider a scenario where a control panel is installed in a location with a high available fault current. If the panel's short-circuit current rating is inadequate, a short-circuit event could cause the panel to explode, sending shrapnel and hot gases into the surrounding area. This could result in serious injuries to anyone nearby. Alternatively, if the panel is equipped with current-limiting fuses or circuit breakers, these devices will quickly interrupt the current flow during a short-circuit event, protecting the panel and downstream equipment from damage. However, it is essential to ensure that the interrupting rating of these devices is sufficient for the available fault current. Installing devices with inadequate interrupting ratings can be just as dangerous as installing a panel with an inadequate short-circuit current rating. The selection of components for industrial control panels should also take into account the short-circuit current rating. Components such as circuit breakers, fuses, contactors, and motor starters must be able to withstand the fault current levels that may occur in the circuit. Component manufacturers typically provide short-circuit current ratings for their products, which should be carefully considered when selecting components for a control panel. It is also important to ensure that the components are properly coordinated to provide effective protection against short-circuit current. Coordination involves selecting components with appropriate characteristics to ensure that the upstream protective devices will trip before the downstream devices are damaged. Grounding is another critical aspect of industrial control panel design and installation. Proper grounding provides a lower impedance path for fault currents to flow back to the source, helping to quickly clear the fault and minimize the risk of electrical shock. Control panels should be properly grounded in accordance with the NEC and other applicable standards. Grounding conductors should be sized appropriately to handle the expected fault currents. Grounding electrodes should be installed to provide a reliable connection to earth. Regular inspection and testing of grounding systems are essential to ensure their continued effectiveness. Arc flash is a dangerous phenomenon that can occur during a short circuit event. An arc flash is the release of energy in the form of heat, light, and pressure, which can cause severe burns, blindness, and other injuries. The severity of an arc flash depends on the magnitude of the fault current, the duration of the arc, and the distance from the arc to the personnel. Industrial control panels should be designed and installed to minimize the risk of arc flash. This can be achieved by using arc-resistant components, installing arc flash barriers, and implementing proper work practices. Arc flash hazard assessment should be performed to determine the potential arc flash hazards in the workplace. Personal protective equipment, or PPE, should be used to protect personnel from arc flash hazards. Proper training is essential for personnel who work on or around industrial control panels. Training should include instruction on the hazards of electricity, safe work practices, and the proper use of PPE. Personnel should be trained to recognize and avoid potential hazards, such as exposed conductors, damaged equipment, and unsafe work practices. Training should be conducted regularly to ensure that personnel are up to date on the latest safety procedures. A comprehensive safety program should be implemented to promote a culture of safety in the workplace. The use of technology can also improve the safety and reliability of industrial control panels. Smart control panels can monitor their own performance and detect potential problems before they lead to failures. These panels can also provide remote access for troubleshooting and maintenance, reducing the need for personnel to enter hazardous areas. Condition monitoring systems can be used to track the performance of critical components, such as motors, pumps, and fans, and to detect early signs of wear or failure. These systems can help to prevent unplanned downtime and extend the lifespan of equipment. The design and installation of industrial control panels should be a collaborative effort between engineers, technicians, and facility managers. Each member of the team should have a clear understanding of their roles and responsibilities. Communication is essential to ensure that all aspects of the project are properly coordinated. Regular meetings should be held to discuss progress, address issues, and make decisions. A well-coordinated team is more likely to deliver a safe, reliable, and cost-effective control panel solution. When troubleshooting an industrial control panel, it is essential to follow safe work practices. Always de-energize the panel before working on it unless it is absolutely necessary to work on it live. Use appropriate PPE such as gloves, safety glasses, and arc flash protection. Follow lockout/tagout procedures to prevent accidental energization of the panel. Use a multimeter to verify that the panel is de-energized before working on it. Be aware of the potential hazards such as exposed conductors, high voltage, and moving parts. If you are not qualified to troubleshoot the panel, seek assistance from a qualified electrician or technician. The documentation for an industrial control panel should be comprehensive and easy to understand. The documentation should include a schematic diagram, a bill of materials, a wiring diagram, and a set of operating instructions. The schematic diagram should show the electrical connections between the various components in the panel. The bill of materials should list all of the components used in the panel, including their part numbers and manufacturers. The wiring diagram should show the physical layout of the wiring in the panel. The operating instructions should provide information on how to operate the panel safely and effectively. In conclusion, the safe and reliable operation of industrial control panels depends on a combination of factors, including proper design, installation, maintenance, and training. By following the guidelines outlined in NEC, UL 508A, and other relevant standards, and by implementing a comprehensive safety program, industrial facilities can minimize the risk of electrical hazards and ensure the safety of personnel and equipment. Remember that short-circuit current ratings are a critical aspect of electrical safety. Always prioritize safety and follow established guidelines when working with electrical systems. This involves not only labeling the panels correctly when required, but also ensuring the panel is rated for the available fault current at its location. The absence of required labeling could result in fines from authorities. However, more importantly, having a panel with an inadequate short-circuit current rating could result in equipment failure, injuries, or even fatalities.